Namaskar, my dear friends. Let us talk about how we can derive the expression for Wien bridge oscillator. So Wien bridge oscillator, you know already the frequency of oscillation will be 1 by 2 pi square root of R1 C1 R2 C2. So whereas you can see we have R1 C1, this is in series, and we have parallel R2 C2, and we have two more resistors, that is RF and R3. These resistors, if you again put it in bridge form, it becomes like this: R1 C1, R2 C2, RF and R3. So what happens is this oscillation is sustained by balancing this particular bridge. Okay, so by balancing this bridge we will become to know like how we can, what is the frequency of operation of this particular Wien bridge oscillator. So we'll have some terms. Let us say there is feedback voltage or feedback voltage signal, that is VF. So this VF signal is nothing but this VF signal from here to here. This is your VF. Okay, and the complete is from here to here, it is going to be your V out. Understood? So similar to that, we have feedback factor that is beta, which is going to be equal to V feedback by V output. So we have the output signal and this one. So can you tell me, I am going to derive this particular expression. So let us say this particular arm is my Z1, okay, and this particular arm is Z2. It means the impedance of R1 C1 is Z1 and the impedance of R2 C2 is Z2. So this is in parallel, this is in series. Now we will start deriving the expression. So what we can do is, from the expression we can see what would be the gain of op-amp amplifier. Gain A is going to be equal to 1 plus RF by 1 plus RF by R3, because it is going to be non-inverting amplifier. So you know already the gain of this one will be 1 by RF by 1 plus RF by R3. Now if we talk about that feedback factor, right, so beta that I told you just now is VF by V naught, and VF by V naught can be seen from the graph, can be seen from this particular diagram, that VF was nothing but voltage across R2 C2, that is Z2, and V naught was voltage across R1 C1 plus R2 C2 both, so that is V, that is this one, right, Z1. So we will write it as, we can write it as Z2 by Z1 plus Z2. That's all. So if you understand up to this, it is very easy to find out what is my Z1 and Z2. So we can write it down. What is my Z2 or Z1? First we'll write down. So Z1 is going to be the series combination of R1 C1, right? So R1 plus 1 by SC1. If you want, you can solve it by 1 plus S R1 C1 divided by SC1. Understood? Similar to that, Z2 is going to be parallel combination of R2 parallel 1 by SC2, right? So impedance of C2 is 1 by SC2. And if you do that, it is going to be R2 into 1 by SC2 divided by R2 plus 1 by SC2. So if we do that, SC2 will get cancelled. So we will get R2 by 1 plus S R2 C2. So we have Z1 as well as Z2. Now by putting these values to beta expression, we will get beta factor, right? So if we can come down, so my beta is going to be equal to Z2 by Z1 plus Z2. So the value of Z2 was R2 divided by 1 plus SR2C2 divided by Z1. Z1 was 1 plus S R1 C1 divided by SC1 plus Z2, that is R2 by 1 plus S R2 C2. Now what we can do is we can take LCM, so that 1 plus S R2 C2 will get cancelled. So I'll do that, and SC1 will go up. So by doing that I can get it as SR2 C1 divided by, this will get multiplied, right? So 1 plus SR1 C1 and SR2 C2 will get multiplied. So what will happen? 1 plus S square R1 C1 R2 C2 plus S R1 C1 plus S R2 C2. So this is the complete term that is coming, plus this one will get multiplied with this one, that is S R2 C1. So S R2 C1. Now from this we can do one thing. We have SR2 C1 divided by, let us take common S, okay? So we can get it as 1 plus S R1 C1 plus R2 C2 plus R2 C1, okay? R1 C1 plus R2 C2 plus R2 C1, and plus S square R1 C1 R2 C2. So this is my beta value. Now if we replace S to J omega, then can we write it down? Beta is equal to J omega R2 C1 divided by 1 plus J omega R1 C1 plus R2 C2 plus R2 C1, and S square will be J square omega square, and J square is minus 1. So I can write it as minus omega square R1 C1 R2 C2. So this is the expression for beta in terms of J omega and omega, right? Now from this what we can do is, if we want beta to be real, so what is required? The thing is that is needed is this 1 minus omega square R1 C1 R2 C2 must be 0, so that J omega R2 C2 divided by J omega this one. So J will get cancelled. It means if this term is made 0, 1 minus omega square R1 C1 R2 C2 is equal to 0, then my beta will be 0. Beta will be real, right? So in that case I can write it down, omega square and you know omega is equal to 2 pi f. I can write it down as, or let us say I can write it down 2 pi f, right? So we will have 4 pi square f square R1 C1 R2 C2 is equal to 1. I am taking one right side. Now from this I can write it down the expression for my frequency of oscillation f, or you can write it down f output is equal to, f can be replaced by f output, so 1 by, what will happen, 4 pi square R1 C1 R2 C2, and this will be square. So from here if I want to find out f naught, so that is going to be 1 by 2 pi square root of R1 C1 R2 C2. So this is the frequency of oscillation that is there for Wien bridge oscillator, okay? And from this my beta value will be what? Since this is 0, this term is 0, so what will happen? J omega will get cancelled, so my beta value will be R2 C1 by this term, right? So my beta value is going to be R2 C1 divided by R1 C1 plus R2 C2 plus R2 C1. That's all. So this was all about the derivation of Wien bridge oscillator. Now let us do more maths. what we can do is, if R1 is equal to R2 is equal to R and C1 is equal to C2 is equal to C, so in that case, can you tell me what will be my F naught? So F naught, what will happen? This will become R and R, so that will be R square C square. So R square C square, square root will be RC. So it will be simply 1 by 2 pi RC. So this is the frequency of oscillation for the Wien bridge oscillator. Coming back to the beta value, so beta value will be RC divided by 3RC. So that is going to be, what does it mean? Like all are like RC, like R1 C1 is RC, this is R2 C2 is also RC, like that I am putting. So RC by 3RC, that is 1 by 3. So this beta value is 1 by 3. Now you know already, for the sustained oscillation, what is needed? My gain must be greater than or equal to 1. That is, A times beta must be greater than or equal to 1. And in that case, I can write it down as A times 1 by 3 must be greater than or equal to 1. So from here, we are going to get my gain must be greater than or equal to 3. Okay. So with this, we have the value A is equal to 1 plus RF by R3, right? RF by R3. By putting the value of A equal to 3, we are going to get RF is equal to, what is that? 3 minus 1, that is 2. So 2R3. So this is another expression. So beta is 1 by 3, F is 1 by 2 pi RC, and RF is equal to 2R3. So hope you have a good understanding of this particular derivation of Wien bridge oscillator. And if you do have any questions or any doubts anywhere in deriving the expression for Wien bridge oscillator, you can put down your questions in the comment box and we shall be able to explain you properly. Thank you.